TN-NTN harmonization. Power consumption management for wireless base stations is important technology. In the beyond 5G era, the ever-increasing amount of power consumed by the increasing number of wireless base stations is becoming a global problem. In the current wireless access networks, power is wasted because all base stations are always on even if there are few people in the area covered by a base station. In response to this issue, NICT is conducting research and development for technology to dynamically and automatically turn base stations on and off based on the results of AI analysis and prediction of fluctuations in the number of people in each area. It is possible to effectively reduce the power consumption of base stations in the areas with few people by allocating non-terrestrial networks such as low Earth orbit communication satellites or high-altitude platform station to the areas where base stations are turned off. By efficiently combining terrestrial networks and non-terrestrial networks, in this way it becomes possible to both provide better communication services and reduce the power consumption of terrestrial base station. In this demo, NICT has collaborated with the Singapore University of Technology and Design, SUTD, to explore the feasibility of integrating TN and NTN using a service-oriented approach. Our demo consists of 4 steps. First, we will provide a quick introduction about our demo setup. Then we start the demo with TN being turned off to save energy, while NTN is on to provide coverage services. Next, when there is user demand, TN will be activated. Finally, when user demand decreases, TN is deactivated to conserve energy. The demo is deployed across to remote locations. Site 1, initially set up at NICT in Japan for testing and later deployed at the MWC booth in Barcelona, Spain. Site 2, located at SUTD in Singapore. These 2 sites are connected via AVPN over the internet. Now, let's look at the main infrastructure deployed at each site. At Site 1, we have deployed an OAI box as a G-Node-B. At Site 2, we are using an open source, OCU and ODU, which communicate with a LAN on ORU over an ORAN working group for compliant interface. At Site 1, we have also deployed an NTN emulator, which is used to simulate the NTN connections between UEs. Let's now move on to the user equipment deployment at each site. At Site 1, a UE connects to AOAI box and ANTN emulator. At Site 2, UE1 is dual connected and is used for HD video streaming. UE2 is a drone. It connects only via TN and is equipped with a 360 camera, allowing for real-time drone control from a remote location. To optimize network efficiency, at Site 1, we have deployed an orchestrator and a RAN intelligent controller that can dynamically manage G-Node-B activation based on demand. At Site 2, a streaming server are deployed to handle real-time video transmission. We run 3 services on the network. First, HD video stream feed from SUTD. Secondly, 360-degree video stream. Finally, remote control drone. This demo only focuses on LEO and GEO as NTN, while there could be other options such as HAPS and MEO. Let's start with TN is turned off while NTN is on. Both UE at NICT and SUTD are connected to LEO. HD video is streamed from SUTD to NICT. This panel shows the local time in Singapore. The latency is about half a second. Now, we switch from LEO to GEO. As the result, the latency increased. We switch back to LEO. The latency is decreasing. Let's move to the next step where TN is turned on. By starting 360-degree camera, the user demand increases. As a result, TN network is turned on. Now, we can start controlling the drone remotely. Drone propeller motor are rotating. We now stop drone propeller motors. Finally, TN is turned off when the user closes 360-degree video stream. We can continue to use HD video stream. For power consumption, OAI box consumes approximately 140 watts. It reduces 28.6% by stopping G-Node-B function. 138 watts is saved by turning off OAI box. This demo is jointly made by SUTD and NICT to demonstrate the feasibility of integrating TN and NTN.